The information in this video comes from thorough research. Please share your thoughts on the video, the science of astronomy, and the structure of the universe in the comments. We'd love to hear what you think. Somewhere, something incredible is waiting to be known. Carl Sagan. The science of astronomy and the structure of the universe. Soft cosmic music fades in. A view of stars drifting slowly across the screen. Above our heads lies a vast, ancient, and mysterious universe, a cosmic ocean stretching across billions of light years. For thousands of years, humans have wondered who we are, where we came from, and what lies beyond the night sky. Astronomy is our ultimate tool for answering those questions. Today, we dive deep into the story of the universe, from the birth of stars to the search for alien worlds, from the discovery of galaxies to the very beginning of time. As we explore this extraordinary cosmic journey, you'll see how humanity went from simple stargazing to decoding the secrets of space itself. This is the story of astronomy, the science that connects us to the cosmos. The dawn of astronomy. Long before telescopes, satellites, or scientific theories, early humans looked up at the sky with curiosity and wonder. They saw patterns in the stars, phases of the moon, and movements of the sun that influenced their lives. The night sky became a calendar, a compass, a storybook, and sometimes even a spiritual realm. In ancient Babylon, astronomers recorded the positions of planets on clay tablets. They mapped the zodiac, predicted eclipses, and noticed cycles that repeated across generations. In ancient Egypt, the rising of the star Sirius signaled the flooding of the Nile, the event that sustained their civilization. In China, astronomers documented comets, supernovae, and sunspots. Their records are among the oldest in the world, stretching back thousands of years. These observations were so precise that modern scientists still use them today. In Greece, astronomy took a philosophical turn. Thinkers like Aristarchus suggested that Earth might move around the sun, a radical idea far ahead of its time. Meanwhile, Ptolemy built a geocentric model with Earth at the center, which would dominate scientific thinking for the next 1,400 years. Across the Islamic Golden Age, astronomers refined ancient knowledge and expanded it with new observations, mathematics, and instruments. They developed astrolabes, calculated planetary motions, and preserved scientific writings that later helped spark the European Renaissance. For most of human history, astronomy was a blend of science, mythology, and philosophy. But everything changed with the arrival of a new idea. The universe could be understood through observation, mathematics, and physical laws. The scientific revolution. During the 16th and 17th centuries, a transformation began, a revolution that reshaped astronomy forever. Nicholas Copernicus proposed a heliocentric model of the universe, placing the sun at the center instead of Earth. Though controversial, his idea planted the seeds of modern science. Johannes Kepler used precise data to discover the three laws of planetary motion. Planets did not move in perfect circles, but in ellipses. They speed up and slow down, depending on their distance from the sun. This was not only a mathematical breakthrough, it was a discovery about the nature of reality. Then came Galileo. With his homemade telescope, he observed craters on the moon, sunspots, the phases of Venus, and the four largest moons of Jupiter, evidence that not everything revolved around Earth. His findings challenged old beliefs, but they opened the door to a new understanding of the cosmos. In 1687, Isaac Newton unified the heavens and the Earth with a single idea: gravity. The force that causes an apple to fall from a tree is the same force that keeps the moon in orbit. Astronomy became a science of physical laws, predictable, measurable, and universal. This revolution set the stage for all astronomy that followed. From classical mechanics to modern astrophysics, it marked the beginning of humanity's ability to truly understand the universe. Modern astronomical tools. Today, astronomy uses tools far beyond simple telescopes. We observe the universe across the entire electromagnetic spectrum, from radio waves to gamma rays, each revealing a different layer of cosmic information. Optical telescopes. These telescopes collect visible light. Some of the world's largest, like the Keck Observatory and the Very Large Telescope, use mirrors more than 8 meters across. They can see distant galaxies, star clusters, and nebulae with incredible detail. Radio telescopes. Radio waves pass through clouds of dust that block visible light. That's how radio astronomy discovered pulsars, mapped hydrogen gas clouds, and detected the faint afterglow of the Big Bang. Infrared telescopes. Infrared light reveals regions hidden by dust, such as star-forming nurseries. The James Webb Space Telescope specializes in this, capturing some of the clearest views of early galaxies. X-ray and gamma-ray telescopes. These instruments observe violent events, black holes feeding on matter, supernova explosions, and high-energy jets streaming across space. Spectroscopy. By splitting starlight into its component wavelengths, astronomers can measure temperature, composition, motion, and even the presence of planets around distant suns. Computational astronomy. Supercomputers simulate galaxy formation, dark matter distribution, and the evolution of stars. Without these simulations, we wouldn't be able to interpret many of the observations we make today. The solar system. The solar system may seem familiar, but it is filled with mysteries. At its center is the Sun, a massive sphere of plasma that contains 99.8% of all the mass in the solar system. Its energy comes from nuclear fusion, converting hydrogen into helium deep in the core. We orbit this star along with 7 other planets. Mercury is a scorched, rocky world. Venus is wrapped in thick clouds and extreme heat. Earth is the only known planet with life. Mars hints at ancient rivers and possible past oceans. Beyond the inner planets lies the asteroid belt, a region filled with rocky debris left over from the early solar system. Then come the gas giants, Jupiter and Saturn, with their swirling storms and dozens of moons. Even farther out are Uranus and Neptune, icy giants with methane-rich atmospheres. And then, on the outer edges, are dwarf planets like Pluto, Eris, and Makemake, worlds of ice and rock orbiting in the Kuiper Belt. Far beyond that, in the darkness of interstellar space, lies the Oort cloud, a sphere of icy bodies that may stretch halfway to the nearest star. Our solar system is only one among billions in the Milky Way, but it is our home, our laboratory, and the birthplace of every element in our bodies. The life of stars. Stars are the engines of the universe. They are born inside giant clouds of gas and dust called nebulae. Gravity pulls material together until the core becomes hot and dense enough for hydrogen to fuse into helium. When fusion ignites, a star enters the main sequence, a stable phase that lasts millions to billions of years depending on its mass. Low-mass stars like our Sun shine steadily for billions of years. When they run out of hydrogen, they expand into red giants, shedding outer layers and forming beautiful planetary nebulae. What remains is a white dwarf, an Earth-sized object with a massive star. Massive stars live fast and die violently. They fuse heavier and heavier elements until their cores collapse, triggering a supernova explosion. The explosion scatters elements like iron, gold, and uranium across space, the very materials that make planets and life possible. The remnant core becomes a neutron star, or, if massive enough, a black hole. These objects are among the most extreme phenomena in the cosmos, with gravitational fields so strong that not even light can escape. Stars create the elements, illuminate galaxies, and set the stage for life. Without them, the universe would be dark, cold, and empty. Galaxies and the cosmic web. Our galaxy, the Milky Way, is a vast spiral of stars, gas, dust, and dark matter. It contains between 100 and 400 billion stars, including our own Sun. At its center lies Sagittarius A*, a supermassive black hole with a mass 4 million times that of the Sun. But the Milky Way is far from alone. It is part of the Local Group, a cluster of more than 50 galaxies, including the Andromeda Galaxy, which is on a collision course with the Milky Way. In 4 billion years, the two galaxies will merge. Galaxies come in many shapes: spirals with majestic arms, ellipticals shaped like glowing spheres, and irregular galaxies distorted by gravity. These galaxies are not scattered randomly. They form clusters, superclusters, and gigantic cosmic webs stretching across hundreds of millions of light years. Between them lie enormous voids, regions almost completely empty. This structure reveals how the universe evolved, shaped by gravity, dark matter, and the afterglow of the Big Bang. Cosmology and the origin of the universe. Cosmology seeks to answer the biggest questions. How did the universe begin? How will it end? And what is it made of? The leading model is the Big Bang, the idea that the universe started 13.8 billion years ago as an incredibly hot and dense point. Space expanded, matter cooled, and the first atoms formed. Evidence for the Big Bang is overwhelming. The cosmic microwave background radiation, the expansion of galaxies, the abundance of hydrogen and helium, large-scale structure of the universe. But the Big Bang is only the beginning of the story. A fraction of a second after the universe began, cosmic inflation caused space to expand faster than the speed of light, smoothing out irregularities. As the universe grew, gravity pulled matter into galaxies and stars. Dark matter, an invisible substance, provided the framework for cosmic structure. And then there is dark energy, a mysterious force causing the universe to expand faster and faster. Today, dark energy makes up about 68% of the universe, while dark matter accounts for about 27%. Normal matter, everything we see, is only 5%. The fate of the universe depends on these forces. If dark energy continues its acceleration, galaxies will drift apart until only darkness remains. This is the heat death scenario, the most likely according to current observations. Exoplanets and the search for life. One of the most exciting discoveries in modern astronomy is the existence of exoplanets, worlds orbiting other stars. The first confirmed exoplanet was discovered in 1992, and since then, thousands more have been found. Some are massive hot Jupiters orbiting incredibly close to their stars. Others are rocky Earth-like worlds in the habitable zone, where temperatures could allow liquid water. Techniques like the transit method and radial velocity allow astronomers to detect planets indirectly by observing how they affect their host stars. New telescopes can even analyze exoplanet atmospheres, searching for molecules like oxygen, methane, and water vapor. We may soon detect biosignatures, signs of life, on distant worlds. The idea that life could exist elsewhere is no longer science fiction. It is a scientific question we may answer in our lifetime. The future of astronomy. The future of astronomy is brighter than ever. New telescopes like the Extremely Large Telescope and next-generation space missions will reveal distant galaxies with unprecedented clarity. Gravitational wave detectors will open new windows into events like black hole collisions and neutron-star mergers. AI will analyze massive amounts of data, discovering patterns humans might miss. Quantum sensors may allow astronomers to detect dark matter directly. We may explore ocean worlds like Europa, Enceladus, or Titan, places where liquid water exists beneath icy shells. These environments could potentially harbor microbial life. Humanity may even send robotic probes to nearby star systems. Projects like Breakthrough Starshot aim to launch tiny spacecraft propelled by lasers, reaching the nearest stars within decades rather than millennia. The universe is full of mysteries, and our tools for exploring it are growing more powerful every year. The story of astronomy is the story of humanity's curiosity. From ancient stargazers to modern space telescopes, we have always sought to understand the universe and our place within it. We now know that we live on a small planet orbiting an ordinary star in a galaxy filled with hundreds of billions of stars, just one among trillions of galaxies. We are the product of stardust, forged in ancient supernovae. We are the universe trying to understand itself. As we continue exploring the cosmos, one truth becomes clear. The more we learn, the more there is to discover. If you have any experiences related to this topic, be sure to share them with us. Until the next episode, be mindful of the energies around you.